Um, Today we have Nicole Davros, who will be presenting results from a project investigating ringneck pheasant nest site selection and nest survival in relation to different grassland reconstructions. These results are just one part of a much larger study that she and her co-author, Lindsay Messenger, are currently wrapping up. So take it away, Nicole.
All right. Well, thank you, Mary Beth, and thanks everyone who might be out there listening. And I know that she's not here today, but I want to say thanks to Jessica for organizing these webinars. I've heard a lot of, I haven't personally had a chance to tune into all of them. Every week I intend to, and sometimes things come up, but I've heard some really great feedback from other people about the talks they've heard so far. And so props to Jess for getting them organized. And it looks like I've got some homework to do because I know that she's got them all recorded, and as of last night, I think they're all on YouTube. So for anyone else who maybe has missed some of the other talks, check out that YouTube link, which I think is in the LTT email updates. So today, I want to give a little bit of, before I even get started, I kind of want to give a little background on the preliminary results that I'll be presenting today. So this is a project that I began in 2014. And when I started with Minnesota DNR in 2012, I inherited this forb interseeding research project that was designed to look at management options for increasing plant diversity in our existing grassland reconstructions. And so specifically, that project was looking at whether mowing or herbicide use could be used to help forb seeds get established in existing stands dominated by warm season grasses, especially stands dominated by big blue stem and switchgrass. So, I know that everyone kind of has different experiences and success stories and failures, but that project was kind of trying to take more of an experimental design research approach to test, whether we could put forb seeds down and then go out and mow once, mow twice, put a high rate of grass selective herbicide down or a low rate. But essentially, we were trying to avoid just killing all the vegetation and replanting. And the Cliff Notes version of that project, the results from that project, is that we didn't have great luck with what we did in the time frame that we did it. And since I'm not a plant ecologist, but rather an avian ecologist by training, and specifically an avian ecologist who was hired to lead our upland game and pheasant research projects for Minnesota DNR, I wanted to take a step back from that project and take a look at whether we really needed more diversity to produce more game birds and pheasants in our grasslands in southern Minnesota. So I admit that I tend to take a bird-centric and in this talk in particular a pheasant-centric approach, but that's just the approach I'm going to take here. And then I also want to mention, that my co-author Lindsay she was recruited onto my team a little over a year ago, and she had the tough job of stepping into an existing project that was entering its final field season and helping take over a large part of the kind of daily, weekly, and seasonal management of the project. And she's done a really excellent job with it. But it's been a large project to manage and hasn't really had an off season, so I've been thankful to have her involvement. And what I'm presenting today is just a small piece of the project. So I'm hoping that we can get some more results put together and we can have her present the other parts of the project, which are kind of looking at hen and chick survival, and brood habitat selection. So with that long introduction, we'll move on. So this slide, maybe some of you have seen it, but even if you haven't, it's probably coming as no surprise. We've kind of entered this recent era of reduced CRP acreages. So we all know the story of grassland habitat loss in North America and in Minnesota specifically. But if you kind of look at a smaller snapshot of time, since 2007, Minnesota has been losing more and more grassland habitat. And that's mostly due to a decline in CRP acres. And at the same time, we've seen a decline in our ringneck pheasant harvest. So this
Nicole,
yeah.
I think we seem to have lost your slides.
Oh, really? Okay, hang on
You're
one second.
sharing, and
okay.
Tanya is saying she can't hear you, but I'll ask her if she can hear me.
Okay, I just put my slides back up. Can people see them?
There, yes.
Okay. All right. Well, I guess unless you hear from more people that people are having trouble, we'll assume maybe it's just Tanya having some issues.
Yeah, I have
Okay.
seen a few others that say they can hear, so I will try not to
Okay.
interrupt again.
Oh, no, that's fine. I'd rather you stop now than we get to the end. So, so we've had since 2007 kind of this loss of CRP, and it's led to a loss in the pheasant harvest numbers. So this graph has quite a few lines on it, but the story I'm trying to tell with this is that the top line, kind of that navy blue line with the filled in circles, is all on what we consider all undisturbed grassland habitat acres in just the ringneck pheasant range in Minnesota since 2003. The line just below that, the black line with the diamonds, is CRP acres. And so the trend lines there are basically the same. And so what's driving those loss of especially private lands habitat is a CRP. I didn't even bother to put other types of private lands habitat on here because there have been very slow, steady but very slow gains in those acreages. Now, the sort of blue line and gray line show both Minnesota DNR held lands as well as Fish and Wildlife Service lands. And so you'll see there's been a slow and steady increase, but not nearly enough to kind of offset the losses of CRP. So private lands habitat matters, and that's been kind of the leading cause of, CRP has been the leading cause of these habitat declines. So, you know, and there's been enough research with grassland birds and in pheasants in particular to know that, you know, having grass on the landscape matters for our pheasant population and our grassland bird populations in general. So we have a pretty good understanding that putting more grass on the landscape leads to more birds. And so sometimes people ask, you know, how much grass is enough? And again, taking a very pheasant-centric view of the world in Minnesota, you know, it's really a question of scale and understanding the basic sort of biology and movement patterns of pheasants. 70 to 80% of hens move less than 2 miles in their lifetime, and some of them don't even move more than a quarter mile or half a mile in their lifetime. Their average lifetime in the wild is about a year and a half. Some of them might be lucky enough to make it to 3 years, but by far and away, they don't move very far and they don't live very long. So there are a few immigrants who move more than 2 miles, but when we think about managing for pheasants, we really kind of have to think about managing on a lower level. And so, you know, we hear a lot about this 9 square mile sort of habitat recipe, and that's kind of based on pheasant biology. Now, my predecessor, Kurt Haraldson, had kind of looked at this idea of these 9 square miles and how much grass is enough. If you think about pheasant habitat kind of at this 9 square mile landscape perspective, you know, how much grass is enough to produce birds. And so he did a study in the early 2000s looking at, they used survey data, roadside surveys in the spring and summer, and they had 15 of these habitat complexes across south central and southwest Minnesota, and they looked at how many birds they had, and these areas varied in the amount of grass on the landscape. And so just as an example, you know, here are 2 of the actual landscapes that he studied. On the left is an area with maybe 1 block of CRP or a WMA and maybe a filter strip running through it, but there's not much green on that slide, and the green is showing grasslands. The white is mostly row crop, and the kind of tannish color are farmsteads. The blue would be up in the top left corner is going to be any sort of wetland. But you know, this is sometimes a typical landscape. Not much grass out there. Most of the grass comes in the form of strip cover. On the right is a complex with a ton of grass. So you see this large complex, some wetlands mixed in, a little bit of woody cover too, but a much more sort of diverse patchwork of habitat on the landscape. And so bottom line is their results showed that regardless of year effects, you know, because of weather, maybe a wet year versus a dry year, when you had more grass on the landscape, you had more birds. And so, you know, if you kind of take a second there to, sometimes these 3-dimensional graphs play with my head a little bit too. So if you kind of ignore that year axis there and just focus on grass and then birds per route, no matter the year, you see an upslope where you have more grass on the landscape, you have more birds. And so that's what that's showing. And they basically were able to model that for each 10% increase in grass in the landscape, you added roughly 33 birds per route. And that translated, if you took that birds per route up to birds per acreage, it actually led to quite a bit of difference. And so I think that they also found that, you know, you kind of maximize your benefit. You got the most bang for your buck at about, I think it's 25 or 35% grass on the landscape. So I'm throwing some of these things out there. You've got, you know, up to 40% grass, maybe 25, 35, 40% grass, 9 square mile complex. And for those of you intimately familiar with Minnesota's Prairie Conservation Plan, that might sound a lot like these corridor complexes. So in the Prairie Plan, you've got the core, the corridors, and these corridor complexes, which are meant to be stepping stones. So from a pheasant perspective, you know, what this looks like on paper would be really good for pheasants. You've got these 9 square mile habitat complexes or project areas. If you can get those up to about 40% grass and 20% wetland, it should be really good for pheasants. All right, so hopefully I've proven the point that you already knew, which is that we know that landscape matters for pheasant productivity. When we have more grass on the landscape, we have more birds. What we don't really know is what the mechanism behind that is. When we put more grass on the landscape, what kind of individual components of productivity go up? Is it nest success that improves, and so you just have more birds hatching? Is it brood success? You hatch birds, but then they have higher survival rates? Is it, you know, is it overall brood success, more hens pull off a brood? Is it individual chick survival? And there's a lot of, you know, I guess we don't really know what factors limit productivity. You know, we think about food being limiting, we think about predators being limiting, and then, you know, vegetation factors into that. Oftentimes we go out and we study the vegetation, look at structure and composition, and again, kind of taking a bird's eye view of the world. I think about structure and composition really as I think about richness and diversity as a means to an end. And so even though there's diversity in my title, I'll just tell you right now, I haven't calculated any indices of diversity. We don't even bother to necessarily identify individual plants. We take account of species richness and note some of the predominant vegetation when we do our sampling. But for me, for birds, I don't think that birds really care what forbs are out there or what plants are out there. I think they just care that there's something out there that provides the structure and composition they need for putting a nest, for raising their chicks or fledglings, or however you want to think about it. So really, to me, that richness and diversity is a means to an end for when you think about it from a bird's perspective. But, you know, so these things can interact too. So so really kind of the question we're trying to get at is, if landscape matters, but we don't really know what the driver behind that is, how do we get more birds when we put more grass? Then as we lose habitat like CRP, and I know we're facing a renewed farm bill here soon, and hopefully we get more acres back on the landscape. But I think that, you know, one thing to consider is that farm bill is always going to ebb and flow with kind of economic policies and crop prices. And so, you know, in those lean times when we are losing habitat, how do we do more with less? If we do have to rely more heavily on our public lands, if private lands aren't out there, or if it's just a few key programs in terms of private lands, how do we kind of maximize what we get out of those if we don't have, you know, a strong farm bill or a strong interest in sort of making private lands, you know, work for wildlife as well too. So you know, with that in mind, we talk a lot about there being a management emphasis on increasing diversity in our public grasslands. And the reasons behind this are, you know, there's lots of reasons. We want to improve pollinator habitat. We want to improve bird habitat, but especially brood habitat. That's usually the argument you hear, is that we want, by having more diversity out there, that we're improving brood habitat. And the thought is that by increasing plant diversity, you get more bird food in the form of these insects. And so that's why we say we need diversity, is to improve brood habitat or fledgling habitat. If we're thinking about songbirds, is that we need more food. By having more flowering plants, we get more insects, which means we have more bird food. So we tend to think about food as a limiting factor, but I put a question mark behind that, because yes, it's true that pheasants grow rapidly in the first few weeks of life after hatch. They go from being, if they're lucky, 15 or 16 grams when they hatch to being adult size in just a few months. And so they need a lot of protein, and insects are a vital, you know, food resource for them. They rely exclusively on insects, almost exclusively on insects for the first like 8 weeks of their life to grow rather quickly. But I'm not convinced that food is a limiting factor for North American grassland birds. I know that there's some people would argue there's evidence from European studies. I would argue that those maybe aren't the strongest studies. And looking at food as a limiting factor is really tough to do. It's really tough to measure. So in the bird literature that I'm familiar with, I've seen, whether we're talking game birds or songbirds, I've seen very little evidence that food is a limiting factor in grassland systems. Grasslands are just kind of productive to begin with, and there tends to be enough, I think there tends to be enough food for them. I've been studying birds for a long time. I've yet to see a grassland bird starve to death. I've seen forest birds starve. If you start to mix in something like blowflies or parasites or pesticides, then it's a little bit different subject. But and there was a recent paper that showed that both a neonicotinoid and one of the chemicals used for soybean aphid control, the chlorpyrifos, that it was a Canadian study looking, I think, at a migratory bird, and they did show that there was weight loss associated with the use of some of these pesticides. So mix in parasitism or pesticides, and I think that food can start to maybe become limiting. But without those in the equation, I'm just not convinced that food can be limiting. Rather, I come from a school of thought that predation is a key limiting factor, but that it's also really tough to make generalizations. We talk a lot about, patch size. We need to have bigger patches rather than smaller patches. We talk about edge effects. Edge effects, having too much edge is bad, being too close to an edge is bad. And then composition of the surrounding landscape, kind of what's in that matrix and how is it divvied up, and that relates back to patch size and edge effects. But generalizations are really tough to make about that. Not all small patches are bad. Not all big patches are good. Not all edges are bad is the argument that I would make. And in fact, there was a study done by T.J. Benson out of Illinois, and they published this in 2013, where they looked at this, this idea of patch size and edges in particular, and so essentially they did a meta-analysis. They reviewed all the existing literature, looking at some bird studies, and so I'll kind of walk you through this first figure here at the top. So the effect type across the bottom is either patch size on the left, edge proximity in the middle, or landscape context. And on the y-axis, they have just kind of the number of reported cases. So in looking at nest survival in particular, which is what that first graph is looking at, when it came to patch size, there were some studies that showed a negative effect of patch size. There were some studies that showed more studies that showed a positive effect of edge size. But there are also roughly half of the studies they reviewed showed no effect of patch size, meaning you couldn't draw any conclusions from that study. When it came to edge proximity, it was kind of, there is more evidence that edges are bad than edges being good, but there's also a lot more studies that show that you can't conclude that there's an effect of edges on nest survival. And then landscape context, most of the studies they reviewed showed no effect. The bottom graph is kind of looking at the same things, but in terms of nest parasitism. And so the one that stands out there is edge proximity, the positive effect of edge proximity. But in a lot of cases, they weren't able to draw any conclusions. So, we're not necessarily worried about brown-headed cowbirds parasitizing pheasant nests, but I guess the point I'm trying to make here is that it's really tough to draw conclusions and say that all edges are bad, all big patches are good, based on some of the evidence that's out there. Some of the other figures from there, just to kind of show some other figures from that study, and looking at the top graph there on the right, that's looking at daily survival rate. And so essentially that's daily survival rate with patch size along the bottom. And so it's pretty much a straight line. And what that's saying is that daily survival rate didn't really vary much in their meta-analysis with patch size. So again, it's kind of hard to generalize and say that all small patches are bad and all good patches are good. And across the bottom, they also look at daily survival rate of nests in relation to different regions. And so some of these studies are coming out of the core Midwest states, some of them out of the East, and some of them out of the Great Plains. And there's some variation there. And again, generalizations are tough to make. You have different predator communities in these areas. And even within those regions, you can go north to south or east to west and have different predator communities. You can have a different landscape and have a different predator community. So hopefully I'm making the point that generalizations are bad, essentially, that it's really tough to know, and it's really hard from us as a perspective of looking at, pheasants in Minnesota to draw on studies, I would argue that, drawing on studies from Iowa or South Dakota or Nebraska or Kansas, where a lot of the other pheasant work has been done, it might not be applicable to us here in Minnesota. And then just to kind of draw on another study that I think, kind of gets into this idea of, that predators are really key to kind of understanding what's happening out there, and that, clarifying who your predators are can help clarify management needs. This was a study done in southern Iowa looking at patch burn grazing. And they were looking at some songbirds in particular, grasshopper sparrows, but they essentially, this figure is showing daily predation rate rather than daily survival rate. So daily predation rate as a function of the percent cover. And so the blue line and the green line, as you get increasing cover of tall fescue in litter, you actually saw daily predation rate go up. So in other words, more litter, more tall fescue, more likely to have that nest be discovered and depredated. Whereas the more forbs you had, as percent cover of forbs went up, your daily predation rate went down, or conversely, your nest success rate went up. So by clarifying who their predators were, they were able to actually kind of break that down even farther and say that, they found that nest losses to mammals and snakes increased with tall fescue and litter, but mammals in particular were less likely to prey on nests with more forbs, and snakes were more likely to prey on nests in recently burned areas. And so knowing that, it may be that you go out and do management. I guess the point here is that you can go out and do management and not actually see. And if you're only measuring nest success, or thinking that you have your suspects as usual when it comes to nest predation, you might do management and you might not see a rebound. You might not see an increase in nest survival, or you might not see more birds, and you might be scratching your head as to why. And it's like, well, I put more forbs down, why don't I see more? Or, hey, we burned this site. I would think the birds would love it. There should be more, fresh green vegetation, more insects coming in. But it may be that the management is shifting your predator community as well as your bird or insect or vegetation community. So it's really hard to generalize. And I'll just say right here that we tried to do some nest camera work with our project and ended up having to kind of let that go. But I think it could work. It's just we had too much other stuff going on. But ideally, we would have been able to clarify predators in some of our sites. But the reason I bring this study up is just, again, to go back to the idea of that that predation, I think, is really an important driver of some of the responses that we see, and that predators might be are responding. There's more and more evidence occurring that predators are responding to the vegetation just as much as they are their prey items. And so these are important things to keep in mind. And so to try and summarize all that up, we have local vegetation, and we think that birds are responding to the local vegetation, and we have food resources, and we think that birds are also picking those spots because they need food. The insects are responding to the vegetation, and then we think of predators as responding to their prey items. And so this is kind of the interaction that we typically think of. But the point I'm trying to make, and I think what's out there in the literature is suggesting this, that food might not be as important as we think it is in some cases, and that we need to keep in mind that the predators are responding to the vegetation just as much as they're responding to the availability of prey that's out there. And so this kind of adds more complexity, I guess, to this web. So with that in mind, going back to the title of the talk, does plant diversity matter? Does increasing species richness and diversity increase our pheasant productivity? And again, is it through some mechanism of increased nest success or chick survival and brood survival? Or are we getting this kind of, could we be doing management and not seeing a result because we kind of failed to factor in the fact that we might have a shift in the predators that are responding to that vegetation or that management as well? And so these things are really tough to measure, and admittedly, our project is kind of, using some proxies to measure some of this. So with all of this in mind, the larger project as a whole is trying to evaluate pheasant nest site selection and nest survival in relation to local vegetation structure and composition. And so I'll refer to this as maybe microhabitat diversity or patch level diversity. But again, we know that landscape matters. We know, we've looked at patch size edge effects stuff. We're really trying to kind of look at within patch, diversity. And then we also want to evaluate hen, chick, and brood survival in relation to this patch level diversity. and then look at brood-rearing habitat selection in relation to this. And then we think we have some data eventually to kind of look at microhabitat characteristics, because this project was designed to try and inform management within grasslands, and specifically our public grasslands. But it turns out that half of the hens we radio collared took their broods to private lands, and in most cases corn or soybeans, and hung out there. And so we are hoping to do some landscape level habitat selection at some point to try and get at that, figure out why they want to leave our beautiful grasslands and go hang out in corn and soybeans. But that's a bit of a tease, because today, just time-wise, I'll just be kind of covering some preliminary, first draft analyses looking at nest site selection and nest survival. Okay, so if you're still with me, still awake after lunch, I've tried to throw in a bunch of pretty pictures. So I realize you're all hitting that afternoon slump. And because it's just preliminary analyses, I tried to throw in lots of pretty pictures to keep everyone awake. But our study areas, we picked out 2 large project areas in southwestern Minnesota. One is the Lamberton WMA complex near Lamberton, and the other one is what I refer to as the Worthington Wells project area south of Worthington. Both of these study areas are roughly that 9 square mile complex that we talk about. They have a good mix of grassland and wetland cover, and I know Lamberton has added some grass since I started this project, so this figure might have changed, but these landscapes, these study areas that I picked have roughly that 15 to 13% grassland cover. And I specifically chose these sites because they had fields, what I'll refer to as kind of WMA units within those project areas, the areas that patch off of a parking lot that were dominated by things like smooth brome or some other cool season grass. Or they had some low diversity warm-seeded native grass mix, like, dominated by big blue stem or switchgrass. And then they had, diverse grass forb mixtures. And so, again, because we're kind of looking at nest site and brood habitat selection and trying to relate survival rates back to that, our goal was to put a bunch of birds on air and radio track them and figure out where they went. And we figured if we captured them in these areas where we had these types of fields juxtaposed next to each other, then we'd be able to figure out what do they like to use, and then how do their survival rates vary when they do use that. So that's kind of what we're looking at. Just to kind of take another view of these study sites, if you're not familiar with them, the Lamberton complex, they're a little bit different. Lamberton's a little bit more compact in terms of how the habitat's arranged. So the yellow designates all the wildlife management area, and there's been a large, I think, quarter section added to kind of the southeast part of it. But that was just recently planted, so really our study didn't involve much work there. But a lot of private lands there as well, both RIM and CRP, and a lot of that is still in CRP. The Worthington area is a little bit different. I'd say it's a little more spread out. It includes mostly the WMAs. It might be a little bit harder to see, but the areas in red are the WMAs, and those units have, that grass wetland mixture for the most part. But then it's got a little bit of Fish and Wildlife Service land mixed in, kind of just south of the center there, and then the yellow is the Okabena-Ocheda Watershed District property. And so this is generally that Worthington Wells project area. So without spending too much time on sort of the methodology, again, our goal was to just capture and radio collar a bunch of birds, put them out there. We did this during the non-breeding seasons between 2015, and we included some trapping in fall 2017, which I'll explain at the end why. We radio tracked them throughout the breeding season to locate and monitor nests. We collected vegetation data at the nest site and nearby random points, and kind of took some standard measurements in terms of canopy cover, vertical density, species richness. So in terms of analyses, for our nest survival, we assigned fates as follows. We had successful nests, depredated nests, abandoned, or nests that seemed to fail for other unknown reasons. It might have been abandoned, or it's just kind of hard to assign whether it was abandoned because of weather. Any nests that were abandoned because of our research activities were thrown out, but we had nests that were abandoned due to weather, and then we had nests that just kind of seemed to be abandoned but couldn't really tell why. So we kind of put them in an other category. For all we know, they had too many run-ins with a predator and just decided to get out of there. And then our approach was to use logistic exposure without getting too much into it. That's basically because I don't know program mark yet, but logistic exposure is just as flexible. The advantage of it is every time you go visit a nest, the time in between nest visits becomes an interval. that's considered basically a coin flip. The nest either succeeds or fails, and there gives you some number of exposure days. The nest was out there for 3 days in between visits, and it survived. The nest was out there for 7 days in between visits, and it survived. Or the nest was only out there for 2 days, and it failed. And eventually, for what I'm presenting today, haven't had a chance to do this, but it'll allow us to use our categorical variables like year or site, project area, or continuous variables, include that nest vegetation data, maybe some time-specific things like time of year, and then random effects. So a little bit more robust modeling approach, and allow us to use model selection to figure out what best explains nest survival. So our hen captures, we had 6 trapping seasons starting between, I think, February of 2015 and then this fall. So in total, we've captured 164 hens to date, a few more birds at Worthington than at Lamberton. I think prior to fall trapping efforts this year, we had, going into last summer's breeding season, we had trapped roughly 125 or 130 hens. So feel like we have a pretty good distribution of capture locations across these study areas, and then some hens did later disperse, which further distributed our sampling. So this is what that looked like. These are our capture locations. So at Lamberton, again, this is where we actually, the site of capture. So our best capture method was to spotlight them at night, driving around in a UTV. So areas where you don't see us covering, it's not for lack of effort, it's due to safety reasons or because most of our managers don't want us driving through their wetlands. So basically, I think we have pretty good coverage. We got everywhere we could, and birds tend to be, clumped up, and so when we hit a hot spot, we tend to catch a lot of birds in that spot that night. So, and then same in Worthington, pretty good distribution. The areas where you don't see birds put on air is usually typically because it just wasn't a safe area or it was a wet area and we couldn't get into it. In terms of nest survival, so if we had about 130 birds, 125, 130 birds going into last spring, we ended up monitoring 99 potential nesting attempts over 3 years. 12 nest attempts did get excluded from analysis. Most of those were because they abandoned due to our research activities. They typically went on to re-nest, but part of our research activities, we needed to capture chicks. Again, that's not a part I'll talk about today, but so to be able to capture chicks, we needed to know a better estimate of a hatch date. It's really hard to figure out when these birds settle into a nest and begin actual incubation. So we would wait for them to get settled into incubation and then flush her once off the nest to float eggs and get a more precise estimate. But in some cases, she wasn't settled for as long as we thought, and so she would end up abandoning. So those nests were excluded. That left us with 87 nests. Again, the approach with logistic exposure allows you to consider each kind of interval between nest visits as a sample. So with those 87 nests, we ended up with 657 monitoring intervals that added up to just over 1,200 exposure days. So in the end, I think it's a fairly robust data set to work with to look at daily survival. In terms of monitored nest locations, again, this is where we actually monitored nests. So just again to kind of show you the distribution of things. I don't really expect you to take all of this in, but blue is hatched, red is depredated, and yellow is failed for other reasons, and probably in this case includes abandoned nests. So you might see in the top right, the Lamberton, we've got all the way to the south, we had one bird who did make a bigger move and went into a newer part of the unit. She's right there, almost bottom center off of the mile measure bar, which I'm blanking on the name of right now. But so that's a case of a bird who moved, about a mile from where we captured her or more. Not really sure why they decided to do that. We had some birds kind of the northwest corner there of the Lamberton unit that decided to go and hang out in basically a filter strip off of the county highway there. And once they went there and were successful, they decided to stay there again. So we do get some movements, but most of these birds end up nesting fairly close to where we catch them within, again, quarter mile, half mile. So fates of those nests included in analysis. We had 55 nests that actually hatched of those 87, 15 were depredated, 9 were abandoned, and 8 were kind of unknown cause. It could be abandonment due to weather. It could be that they got spooked by a predator and abandoned. So 55 out of 87, if you look at that, that gives us an apparent nest success rate of about 63%. But for anyone familiar with nest survival analyses, just taking the number successful over the number the total number monitored is not really a legit way to do it, because you have all these nests. You have to factor in the fact that there are nests out there that were successful that you never monitored. There were nests out there that you never found that weren't successful. And so really the best way to do it is to kind of calculate this daily survival rate that takes into account the nests you did monitor, the fact that you found them at different stages, and that in this case, that DSR is fairly high. It's 0.977, and that's just a constant survival model. Again, our eventual goal is to factor in some of that vegetation data to kind of look at how that vegetation might play a role in determining whether a nest is successful or not. But that 0.977 is fairly high. You know, the range still puts it at or above some of what's reported in the rest of the literature, whether we're looking at grassland songbirds in general, or grassland birds in general, or pheasants specifically. If you take that daily survival rate of 0.977 and you extrapolate it out to a 23-day incubation cycle, that gives you an overall nest success rate of roughly 60%. That means that that 60% of nests have a chance of making it through that entire incubation period. So that's also pretty high compared to what's reported in literature. But we expected that. We specifically chose these study areas, these project areas that have a lot of grass. So we expect a fairly high nest success rate. We know that putting grass on the landscape matters. Our question then is how to manage within that in terms of that patch level diversity. So having a high nest success rate isn't really too surprising because of how we designed the study. And again, these analyses are just kind of a first look at, you know, what you're going to see in these next series of figures is just means and standard errors. But it's kind of a first look at what we're dealing with, where we're starting to see some variation. So first up, we're looking at nest site selection. Where did hens put their nests versus random points nearby vegetation that they could have chose. So this first graph is looking at percent canopy cover of grass, forb, and standing dead across the bottom. And so maybe a little separation there in terms of forb cover. So it looks like hens are choosing sites that have less forb cover than the random points nearby. And it looks like they're also choosing sites that have more standing dead vegetation than random points. In terms of the species richness, we looked at kind of total species richness, how many different species of plants were in our quadrats, and then specifically we broke it down into grasses and forbs. Not too much separation here, if anything, maybe a little bit higher species richness in the random points compared to nest sites, but some overlap there. And again, this is just kind of a really rough analysis of what we're dealing with in terms of this data set. So we'll see if any of that shakes out in the end and ends up being important. In terms of litter depth, they're on the left, looking still at nest sites versus random points. It looks like hens were choosing sites with less litter than random, but I think that's easily explained by the fact that hens start to drop eggs before they've really even put a scratch into the ground. They kind of start laying eggs, and as they lay more eggs and start to incubate, they form more of a nest bowl. So I think the fact that we found less litter outside of the nest bowl at these nest sites compared to random points is just an artifact of the fact that as she sits there and lays eggs and incubates them, she pulls in vegetation from nearby, and it's not like a songbird where she's carrying vegetation, you know, across and putting it there. So I think that's just kind of an artifact of kind of how they nest. In terms of vertical density, they're on the right, really not much separation between nest sites and random points, and that's we used Robel poll, the Robel method to look at vertical density. Okay, now taking just the nests and separating that out into their fates, whether they hatched, were depredated, or abandoned. I wanted to look at whether we, first take is looking at, do we see anything in terms of hatched versus depredated nests that might be different? And so that's what these next set of graphs are looking at. So first up here we have canopy cover on the left-hand axis, and across the bottom, the first set of three is looking at grass cover. This next set is looking at forbs, and that third set of colored bars is looking at standing dead vegetation. And so I want to draw your attention to the middle there, which is forbs. And so this looks like hatched nests generally had twice as much percent canopy cover or forbs compared to depredated nests. not too much separation in terms of grass cover and standing dead cover. So what really stands out there to me is that forb cover might be playing a role in terms of determining nest fate. And that's something we need to explore further. In terms of species richness, we start to see a little separation, you know, in terms of the mean of species richness total and forbs between hatched and depredated, but those error bars are pretty wide, and again, this is kind of just a first look at what the data is looking like, so not sure how that'll shake out either. And again, looking at nest fates in terms of litter depth and vertical density, not really seeing too much here as well yet, so we'll see how that shakes out. But to kind of summarize that, again, we have fairly high nest success, and we expected that because we purposely chose these large project areas that should have high nest success. So if you kind of break that down into, you know, within that what's happening with how hens are choosing nest sites and then what that might mean for the fate of that nest. It looks like hens are tending to choose sites with less forb cover and more standing dead vegetation than random points nearby. So they're choosing sites that seem to have less forb cover than what's available, but yet successful nests had 2 times more forb cover than depredated nests. So that's kind of interesting. They're not necessarily choosing sites that are really forby, but when they do have more forb cover, they do better. And again, these are kind of just first take through these analyses. We'll see if this trend holds up in some of our more in-depth modeling. The standing dead cover, the fact that they're choosing sites with standing dead isn't really a surprise, you know, especially early season nesting attempts. Like they're, you know, not much would be greened, you know, have greened up yet. So standing dead cover is important, especially for these early nest attempts. So that's not too surprising. We see a modest difference in total species richness between nest sites and random points nearby. And again, don't know if that means anything yet. So that's something maybe for us to pay attention to. And then again, this nest sites had shallower litter depths than random points, but I think that might just be an artifact of the building the nest bowl after the nest is initiated, rather than building a nest bowl before she lays her eggs. So this is what we've got to work on so far, and you know, but I'm excited to see this because again, we're kind of interested in looking at, does diversity matter? And so far, the first take through this is suggesting that forbs might play a role. That even though they might not select sites that have more forb cover, when they do, they might have higher nest success, and that's, you know, that would be a key thing, you know, to walk away with knowing in terms of how we should think about managing our grasslands. And whether we should be investing in, I guess, you know, the point there is that, you know, ultimately our goal is, do we need, going back to that forb interseeding study, do we need to think about putting money into, you know, these reconstructions and getting them to be more diverse, or do we, in some sense, manage them the way they are, cut our losses, and focus our time and our resources and our money on acquiring new land? And so that's kind of what we're hoping to come out with. And so I'm excited to see that you know, some of that is starting to separate in the data. So in terms of ongoing or future work, we're continuing to monitor our remaining hens for survival. So even though this is kind of geared towards breeding season, you know, big shocker here, a lot of our hens die outside of the breeding season. So so it's really important for us to kind of continue. We know that survival is not discrete, you know, within the season, and so we're monitoring our hens to figure out, you know, when and where they're dying. And then obviously, you know, this is a first step in data analysis, so I'm excited to kind of get into more robust analyses and kind of take that model selection approach, incorporating that nest vegetation into these daily survival rate estimates and figuring out, you know, what really might be important in explaining nest success. And so I mentioned that one of the, you know, we were out this fall trapping hens, and we actually did put more birds on air. And so even though the main part of this project has wound down, I have a companion study going on, collaboration. It's an LCCMR, and Environmental Natural Resources Trust Fund funded project to look at insecticide exposure risk for our grass and wildlife on public lands, kind of evaluating, you know, how much drift occurring and how far does it drift. If we have a public grassland or a private grassland adjacent to these fields, how far does it drift? And I think it has really big implications for the buffer law. You know, we want to maybe build these buffers and have them be beneficial for wildlife and pollinators and birds, and so kind of getting at that question. And I know Eric Runquist and Robert Dana gave a presentation, the first presentation of the fall, and they're kind of looking at this, and so I think our sampling design is a little bit different. I'm really hoping that between the data they've collected and that we'll be collecting, we'll really kind of be able to say something about aphid spraying in particular in southern Minnesota, because it's been an issue that's been on everyone's radar for a while. But as part of this project, we're looking at both the direct and indirect effects of aphid spraying on birds, insects, and the potential implications for other grassland wildlife. But it's a collaboration with the University of Minnesota Cooperative Fish and Wildlife Research Unit, and in particular, the research scientist, David Anderson. He and I have recruited a grad student, Caitlin Goebel, who's in the middle there in the team of people in yellow suits. And so her master's project is looking at this potential for drift, and then she's also using some of our marked birds to look at some other questions related to that. So one of the things we're hoping to figure out is look at home range of these hens and their chicks when aphid spraying is occurring. Do we see home ranges shrink after spraying? If we do, then that would suggest that these birds aren't feeling very well from getting sprayed and they're not moving as far. Or maybe we see home ranges expand, which tells us the birds are fine, but they have to go farther and wider to find food. And so that's one component of it. And so she's relying on some of our marked birds, and so we put more birds on air this fall. So that said, I think we have an opportunity to supplement some of our existing data set to kind of add to our sample sizes that we already have. So that's some future work that I consider a companion or I guess a related study to this pheasant project. With that said, hopefully everyone's still awake, and at this point I can take any questions or comments. Yeah, thanks for tuning in and being patient with us as we get some of these analyses done and get the results out there.
Well, thank you, Nicole. That was very informative, and been hearing about this study along the way, so it's exciting to get some results. And I do have one question, and I encourage others to type a question in the box if you have it. This one's from Jeff Zajac. He wrote it early on when you were talking about, the various factors, and he asks, is it the total amount of food, meaning insects, the chicks eat? Is that the most important variable, or the amount of time needed to forage for that food? I.e., does mortality to weather and predators increase with the amount of time needed to acquire that food?
Yeah, I'm surprised Jeff didn't ask me about the 9 square mile complexes. I know that's one of his favorites too. No, I mean, that's a really good question, Jeff, and I think that, that's a tough one to answer, and we've tried to document along the way. So one of the things I didn't talk about today, but hopefully if Jess continues this, or in another forum we can present some of those results, is we did also radio tag chicks individually, and you maybe saw that in some of the pictures. There was a chick with a little antenna coming off its back, and so we have spent so much time and money looking at nesting across the bird world, and we've really not paid attention to what happens after they leave the nest. And so for the sake of I don't know, just making verbiage easier, I'm going to refer to pheasants leaving the nest. I mean, you can call them hatchlings, but I'm going to call it fledging, right? They don't really sit in the nest as nestlings. As soon as they hatch, they pretty much leave the next day. But we've paid very little attention to that juvenile survival period, is probably the better way to phrase it, whether we're talking songbirds or game birds. And so we don't really know too much about that. There's been a few studies that have tried to look at game birds and look at individual chick survival. Normally we use some sort of proxy, like you go and you flush the hen and you try to count the number of chicks she has left, and that's potentially very inaccurate. You get brood mixing and things like that. So it's really hard to measure those things. And so we've tried to so we have these chicks that are marked, and we've tried to document when they die. We try to take pictures and assign a cause of death. Sometimes it's really unclear. Sometimes it's like, yeah, it got a little cold last night, but this chick looks like it was munched on too. And did the mortality happen due to a predator, and then it sat out and got and it got wet from exposure because you get dew overnight, or did it die of exposure first and then something came along and started to scavenge on it? And so assigning a cause of death with these chicks has turned out to be pretty difficult. And I know there's a study out of Iowa that actually did assign cause of death, and I don't think it is accurate. So, so that's something for us to do. But there's definitely this interactive effect. And the question of, is it abundance of food or is it just time to forage? It's probably all of the above, right? I'm sure at some point food could become limiting. Like, again, if you mix in pesticides or things like that. But I think it's also time to forage. They need to be able to keep up with the hen. They need to, while they're keeping up with the hen, escape predation. They need to be able to find food. You know, if you know, if you've ever seen pictures of these little chicks, oh, well, here, I have one here. You know, look at this little chick here on the right. You know, that thing's got to get through all of that litter and keep up with the hen and pick bugs and get at them through that litter, and at the same time not get tangled up in the vegetation if a predator comes along. And so I guess it's a long-winded way of saying, Jeff, I don't have an answer. It's a really tough thing to measure, and we're trying to measure that with this. But I don't know that we'll have an answer in the end either, just because it's so tough to measure. I think all of the above is important. And I think that when you think about management, you know, that's something. So again, we hoped to assign cause of death of chicks. We hoped to actually put cameras on nests and record predation events. That ended up being tougher than expected, and so we dropped that portion of it. But I'm hoping that in the end, you know, with all this vegetation data we're collecting, not only around nest sites, but around brood sites, that we'll be able to relate some of these vegetation variables back to survival and come up with management. If we find that forbs matter, survival is indeed higher for nests or for chicks, then it's like, yeah, we need more forbs. But if it turns out that, you know, forbs are important for nests, but litter depth or amount of litter cover is important in explaining chick survival, then maybe we say, hey, we need to burn more often, or we need a management technique that doesn't allow that litter layer to build up so these chicks can have a higher survival. And the mechanism behind that, whether it's they're not finding food because there's too much litter to get through, or they can't keep up with the hen or the predator, is interesting, but it might not be important as long as, like, we can, you know, explain survival rates. So one is explaining that survival rate, and one is understanding what's driving that. So again, kind of a long-winded answer for that, but I think it's all of the above, and I think it's really tough, and I'm hoping that we can use some of the proxies that we are, of, like, the variables we're measuring to shed some light on that.
Okay, good. A couple more questions. Brian Lewis says some recent turkey research with GPS marked regularly satellite located hens would indicate nest site selection may more likely be, oh my God, I'm going to lay an egg, here's a good spot. They had never been located at the spot they ultimately chose.
Yeah,
or they choose.
So I remember him telling me about that. I wish the technology was there for pheasants to be able to get this, like, fine-tuned data. You know, we do know that, so it's a little bit different for pheasants, right? Like, most of our birds end up nesting, and that's something we can look at, is where was their first nest attempt versus where we captured them. In some cases, it's within meters, and so that might be like they were getting ready to nest and they were just hanging out there. You know, I think the one year we did push our spotlighting efforts into, like, April 20th or something, so maybe she was getting ready to lay an egg and that's where she ended up. But in general, even birds caught earlier, they don't move very far. Sometimes it's less than a couple hundred meters, and sometimes it's maybe a quarter mile. So yeah, it could very well be random, and it's just that pheasants just don't move very far. I wish I had wings to get up and fly, and so it kind of, it's funny to me that pheasants don't like to get off the ground more than they have to sometimes. But so it could very well be random. But I just don't think we know, and the technology's not there for pheasants. I wish it was. You know, we have these hens who hatch, and within a day, they march their brood more than a mile or two away from where they hatched. And it's like, how did they know that was there, and how did they get there? And in some cases, it's like they've made a beeline for, like, there's very little alfalfa or small grains, but in some cases, that's where they go to right away. In the two study areas, it's like, how did this hen know that was there, and how does she get her chicks there when they have a road to cross and a creek or some sort of water body and basically a soybean field? Like, what route did she take? And so I would love for the GPS data to be there to kind of look at what these birds are doing in the interim, but it's just not there yet. And this is old-fashioned VHF telemetry, and it leaves a lot of questions to be answered, I think. But yeah, it could very well be random, but we'll see.
And finally, Jeff Zajac asks, where was that really pretty prairie picture taken?
Oh, Jeff, this last one here?
Mm-hmm.
I'm assuming this is also high diversity out at Lamberton. It's just trying to brag about his high diversity plot over there. But it is beautiful. And actually, my grad student took this picture, so credit to her for this one. But they took a lot of pictures, and we kind of took over control of them so that they became our property too. So yeah, I think that this is also out at the high diversity Lamberton plot, which is the reason why we chose Lamberton in particular, because this is one of the sites where we literally had this right across the road from switchgrass and big blue stem, and it was the perfect opportunity to just put birds on air and see where they go.
Wow. Well, beautiful. Well, thank you so much, Nicole. Very interesting.
Well, thank you everyone for tuning in, and yeah, feel free to email me if you have any questions.
Okay, well, yes, I'd like to thank everybody for joining too. We're coming down to our final weeks for the next year, and next week we have Ian Lane from the University of Minnesota, and he'll be discussing the role of the agricultural matrix in shaping bee communities and prairie restorations and remnants. So hope to see everyone back then. Thanks again. Sign off.